All right, guys, this is going to be the second lesson of this week. So there's only one more after this one. That's going to be on Thursday. Just a reminder also, yesterday's homework, or the lesson that you guys got yesterday, that homework that came with it, that's going to be due by the end of the day, so 11:59 tonight. So make sure that's get done if you haven't finished it already, okay? We're going to go ahead and jump in. So today's topic is going to be areas of circles and sectors, all right? So some essential understanding you will need to know. You can find the area of a circle when you know its radius. You can use the area of a circle to find the area of part of a circle formed by two radii and the arc the radii form when they intersect with the circle. So again, the area of a circle, we probably know this is area equals pi r squared. So make sure you have the radius, and that's going to be squared. Okay. Again, whenever we have pi, make sure you understand what they're asking you to solve for. It could be in terms of pi, it could be in terms of round to the nearest tenth. Make sure you know what they're asking you to solve for, because that will come kind of into a factor for some of our answers. All right, example 1. Finding the area of a circle here. So for our problem here, it's asking for area. So if we write down our formula for area of a circle, it's A equals pi r squared. Now, if I think about the circle that's there, I'm looking for radius, and unfortunately, I don't have radius. They gave me the diameter, so I have to find diameter to radius. So again, if radius is half the diameter, then that means our radius here should be 16, because 32 divided by 2 is 16. So we have A equals pi 16 squared. And again, all we're doing here, guys, is simplifying. So 16 squared does give us 256 pi. So if they want it in terms of pi, you would say 256 pi. But also understand that if they say round to the nearest tenth, it could also be, again, if I type that into my calculator, our answer would be right around 804.2. So just know that these are the same answers, but just understand what they're asking you to solve for. If it's nearest tenth, type it all in your calculator. If not, leave it in terms of pi. So you could see both answers. You don't have to write both. Just know what you're solving for. Okay, the next one here, sector of a circle. So a sector of a circle is a region bounded by an arc of the circle and the two radii to the arc's endpoints. So you name a sector using one arc endpoint, the center of the circle, and then the other arc endpoint. So again, as you can see in the example right there, it is sector RPS. Again, it's your two endpoints with your center in the middle between those two endpoints. Very simple. The area of the sector is a fractional part of the area of a circle. The area of the sector formed by a 60-degree arc would be written as part over whole, which is the 60, over a whole circle, which is 360, which again, when reduces down to 1/6 of the area of the circle. Okay, so to find the area of a sector of a circle, it's quite simple. So again, it's always going to be part over whole. So again, the measure that's highlighted there, it's going to be the measure of that arc, whatever that degree is, over the whole degrees, part over whole, times area of a circle, which is pi r squared. So we're just putting everything together. Like yesterday, we learned part over whole. Same thing today. We're introducing that part over whole, and we're multiplying it times the area. Okay. So let's take a look here. Example 2. Finding the area of a sector of a circle. So again, like we said, it's going to be the part over whole times the area here. So let me write that. It's part over whole times area of a circle, which is pi r. I don't know what happened with there. Pi r squared. Okay, so pi r squared. So the part that we're looking at there, that part would be 72. That's the highlighted part. So 72 over 360. That's part over whole times pi r squared. Luckily, they do give us the radius there. The radius there is 15. So it's pi times 15 squared. So again, from here, all we're going to do is simplify. 15 squared is just going to be 225. And you can simplify that fraction if you want to. You don't have to. You can leave it as it is. But 15 squared would be 225 pi And then again, you would multiply that times 72 over 360. Now, again, they want this in terms of pi, so I will have to multiply 225 times that 72 over 360. So again, if you were to type that into your calculator, it should simplify down to, after you multiplied it all, should be 45 pi. And again, it does want you to leave it in terms of pi, so this would be our final answer. If it said round to the nearest tenth, just type that into your calculator and simplify, okay? All right. Segment of a circle here. So here's probably going to be the hardest part that we'll be covering, but this will be the last thing that we cover. A part of the circle bounded by an arc and the segment joining its endpoints is a segment of a circle. To find the area of a segment for a minor arc, draw radii to form a sector. The area of the segment equals the area of the sector minus the area of the triangle formed. So again, this is a great picture. This is why I love this part here. So again, it's the area of the sector, which is what we just saw for on the example above. We're going to subtract the area of a triangle here. So again, I'll show you how we can do that. Again, area of a triangle is base times height divided by 2. And then that should equal the area of the segment, okay? So there's two parts we're really solving for here, okay? So what is the area of the shaded segment below? So again, first part, let's find the area of the entire sector. So again, if the entire thing was highlighted, just like we did in example 2 there, what would that area be? So again, that formula, if we're looking for the entire sector, then that would be A equals part over whole times pi r squared. It's that same formula we use in example 2. So if you need to back up to make sure, that's that same formula that we used before. So again, the part over whole. Now, if they give us a central angle, remember, central angles go with the arc. So again, those should be the same. So if that central angle is 60, that means that this arc will also be 60 as well. Okay, so part over whole would end up being 60 over 360 times pi r squared. Luckily, they do give us our radius here. The radius here is 18. So pi 18 squared. All right, so from this part here, I'm going to leave it in terms of pi for right now. I know that our final answer will be in terms of tenth, but I think it's a little bit easier to leave this in terms of pi. So when I multiply it out, I would get 18 squared, and then 18 squared times 60 over 360, when simplified, would simplify down to 54 pi. Like I said, this is not our final answer. This is if the entire thing was shaded right there. So again, we're not done yet. So we've got the first part done, the area of the sector. Now the second part we need to find is area of a triangle. So I'm going to move down to the next page here, but we're still looking at the same problem. Okay, so area of a triangle, that is A equals base times height divided by 2. Okay, so we know we had a triangle here. So here was our triangle where the angle was 60 degrees. 60 degrees. Okay, so knowing that, remember, we need to find the height. We know the radius, that if we go back to our previous picture there, the radius was 18. So what I want to do is I want to find the height and the base of that. Because again, I don't care about the side lines. All I care about the base and the height. So I'm going to draw a perpendicular line right there. So again, that's going to form a 90-degree angle right there. So that perpendicular line bisects this angle of 60, which means that each of those two smaller parts right there are each going to be 30. So that's 30, and that's 30 as well. Okay. So I have a 30, I have a 90, which means this angle right there is 60. So we're looking at a special right triangle right now. So again, from a special right triangle, this is my short leg. This is my long leg. So to go from a hypotenuse to a short leg in a 30, 60, 90 right triangle, we divide by 2. So if that part is 18, that means this short leg right there is 9. To go from a short leg to a long leg, that means that we're going to multiply, because we're getting bigger, times radical 3. So the height, or the altitude of that triangle right there is going to be 9 radical 3. The entire base is also going to be that same side length. So 9 and 9, that means our base is going to be 18. We have our base, we have our height. Plug it into our formula here. So it's going to end up being 18 times 9 radical 3 all over 2. All right, and when I look to simplify here, that should, when I end up reducing this, equaling, so that's going to be 81 radical 3. So again, remember, so from that previous problem, we can see it right there. The area of the entire thing was 54 pi. The area of the triangle is 81 radical 3. My last step is to write it as we are subtracting those two parts. So the sector minus the triangle. So that's going to be 54 pi minus 81 radical 3. And all you have to do, guys, I'm not expecting you to know this, just literally type that into your calculator. 54 pi minus 81 radical 3. You're going to get a decimal, that's fine. Round to the nearest tenth because that's what our question told us to do. And when rounded to the nearest tenth, your answer should be 29.3. Okay. So quite a few steps there, but if you take it piece by piece, it's not as bad. It's not as bad. So just make sure you know what you're looking at. Make sure you know your special right triangles. Again, it's just kind of inferring everything we've learned so far this year. All right. So homework. So you guys know the routine by now. Again, just a reminder, yesterday's lesson, that homework is due by tonight. Today's lesson, that means that'll be due tomorrow at 11:59. We are going to be off on Wednesday. So just a reminder, we're off on Wednesday, and then I'll have another lesson for you guys on Thursday. But virtual office hours will still go on Monday through Thursday. Okay, so I'll have mine today from 1 to 2. Please feel free to attend, guys. And then if you have questions, you can remind me. You can email me. Find some way to get in contact with me, and I'll find a way to get back in touch with you guys, okay? Just know I'm here for you guys. If you need anything, I will always be here. So in the meantime, I will see you till next time, guys.